Mathematics has a lot of shapes. In geometry, there's a cube, trapezoid, square, rectangle, circle, sphere, amongst the ones that you know. In algebra, there's no singular more important shape than the parabola. The parabola itself is a useful tool to describe many things in algebra, but in particular, algebraic expressions. Algebraic expressions can be represented as equations or as a parabola or some variation of a parabola. This U-shape accurately describes different types of algebraic expressions, in particular quadratic expressions, quadratic equations. The most important quadratic equation that it does define is found in a form known as the vertex form. The vertex form of a quadratic equation concisely and neatly describes points on a parabola. In particular, not just any points, but the vertex. From the vertex you can find the zeros and so on. I'm not going to get into the weeds on this. Many times we're tasked to convert from the standard form of the quadratic equation to the vertex form of the quadratic equation. The method known to do this is called completing the square. Keep in mind that quadratic equations represent points on parabolas, on graphs. It is very important to represent the quadratic equation in different forms. As with most things, we have to start off with our rules. To factor using completing the square, you have to do these 3 steps. Step 1, move the original c to the other side. You can do this using the inverse. Step 2, take half of the b value, square it, and add it to the other side where you put the original c, as well as the main side where the original c was moved from. Step 3, zero out one side and factor using the methods we've done before. That is, factor using grouping, factor using GCF, factor using the AC method, factoring using the quadratic formula. We haven't gone over the quadratic formula yet. So let's look at 3 examples to see exactly what I'm talking about. Screen, please. Thanks. Problem 1. Before we get started on the problems, just as a note, factoring using completing the square isn't exactly a whole form of factoring as factoring using grouping or factoring using the AC method was before. It's generally a conversion from standard quadratic equation form to a vertex quadratic equation form. Many times you'll be forced to use another form of factoring afterwards. Okay, now let's continue. First problem, x squared minus 2x minus 15 equals 0. Going by our steps, we're going to move the negative 15 over to the other side. So now we have an expression of x squared minus 2x equaling positive 15. The next goal is to be able to convert the left-hand side to a perfect square trinomial. To do that, we have to follow the other steps. The other step, step 2, says for us to take half of the b value, in this case 2, and square it. Half of 2 is 1. 1 squared is going to give us 1. So the new expression on the left-hand side is going to be x squared minus 2x plus 1 equaling 15. The left-hand side is in perfect square trinomial form, meaning it makes it easier for us to convert to a vertex form of a quadratic equation. That expression you see like so. It's going to be x minus 1 squared equaling 15. What you can do now is to convert everything back to a trinomial and factor, or you can leave it in the true vertex form, moving the 15 back over to its original spot, leaving you with a vertex equation form of x minus 1 squared minus 15. If you're asked to find the roots, you have to convert that back to a trinomial. Using inverse operations, you can see a result like what you see before you here, leaving us with an answer of x equaling 5 and x equaling negative 3. Those are the roots. Take a minute, pause, and look at the workings in front of you. Try to understand the difference between a vertex equation and solving the quadratic equation. Many times they'll ask you for either one of the two or both. Also, take this time now to smash that like button, comment, and of course, subscribe. It helps me create better content for you. So, on to problem 2. X squared plus 2x equaling 35. In this case, they already moved the c value over for us, so step 1 is not needed. So step 2, we have to take half of the b value. Again, the b value is the value that's next to the x, not the x squared, and square that. Like the last example, we're going to get positive 1. The positive 1 has to be put on both sides, like so. You're gonna have perfect square trinomial on your left-hand side. Factor that out, and you're going to be left with x plus 1 squared equaling 36. If you want the vertex form of a parabolic equation or quadratic equation, you will just leave it as x plus 1 squared minus 36. But if you want to find the roots, you have to incorporate 36 back into the perfect square trinomial, like so. Doing this leaves us with just two answers, x equaling -7 and x equaling 5. For those of you who don't know, to factor a trinomial like this, you look to add up to the middle term and multiply up to the end. Again, I'll leave exercises or links to exercises in the description below to help you guys out. Problem 3. Yeah, if you look at that chart that I mentioned a few videos ago on difficulty levels, this one would probably be about a 4. So let's go ahead and put it up on the screen. The problem says 2x squared plus 8x minus 7 equaling 0. This time, you actually have another value on the opposite side. No matter, you still have to move your c value from the original side to the other side. So that happens like so. After that, one thing I didn't mention before, because we didn't come across problems like this before, was that you have to isolate the x squared, meaning that you have to get x squared coefficient, which is a number before the x squared, to be 1. In order for that to happen, you have to divide everything by 2. That happens like so, leaving us with an expression of x squared plus 4x equaling 5 over 2. Now, if we're following our rules, step 2 tells us that we have to divide b by 2, and you get 2, and then square it. So x plus 2 squared gives us 4. So we're left with an expression of x squared plus 4x plus 4 equaling 5 over 2. We ain't done yet. The left-hand side, we have the perfect square trinomial that we desire. We can get this into a vertex form. The vertex form is going to be x plus 2 squared equaling 13 over 2. If you remember, when we added the 4 to the left-hand side, we also had to do the same to the right-hand side, leaving us with 13 over 2 on the right-hand side. Then, if we wanted the vertex form for the quadratic equation, we have to move the 13 over 2 back to the original side, leaving us with an expression of x plus 2 squared minus 13 over 2. If we're asked to find the roots for this one, it's going to be a lot easier to use the quadratic formula, which is minus b plus or minus square root of b squared minus 4ac over 2a. In a future video, I'll show you how to factor, not really factor, but how to break down or get real roots using the quadratic formula. But for our intents and purposes, let's just plug in the letters a, b, and c that we have from our quadratic equation into the variables in the formula, like so. Keeping in mind that we have to adjust the original perfect square trinomial to now be x squared plus 4x minus 5 over 2. Plugging everything into the quadratic formula and then working out the small math, you're going to be left with two answers. They're actually going to be in radical form. You're going to have -4 plus the square root of 26 over 2 and -4 minus the square root of 26 over 2. Yeah, it can get confusing sometimes. Guys, we're gonna stop here, but we're gonna pick this back up next week and just remain on the topic of factoring. Again, in the description below, you'll see links to practice worksheets where you can practice this, as well as some of the other methods of factoring that I have on my channel and also on the video descriptions. If I leave you with a statement for you to remember, it'll be always practice. It sounds cliche, but with enough practice, you do get a lot better. Stop the video, rewind it, go forward, rewind it, go forward. Use other channels, whatever it takes to make you get better. Once again, I'm a knowledge guy, AKG. I'll see you next week with another video.